Hi students, we will discuss about empirical formula. Empirical formula means what? The formula represents the chemical composition of the substance. For formula represents the chemical composition of formula represents the chemical composition of the substance. Chemical composition of the substance. So there are three kinds of formulas is there. Formula of compounds. What is that three? First one is empirical formula. Second one is molecular formula. Third one is structural formula. So these three types of formulas we have. So empirical formula about we will discuss now. Empirical formula. What is empirical formula? Simplest formula of the chemical substance. Simplest formula of a chemical substance. Simplest formula of a chemical substance. Simplest ratio or simplest formula of a chemical substance. This formula indicates that ratio of number of carbon atoms or number of hydrogen atoms, whatever it every element have some empirical formula. Simplest formula also is there, so that we will discuss now. It is the formula of the substance which gives the relative whole number ratio. Relative whole number are simplest whole number ratio of atoms each element present in the molecule of a substance. For example, I will take example, empirical formula example. C6H6 is there. So for this one, simplest ratio I will say CH, 1:1 ratio of carbon and hydrogen combined. That means 1:1 ratio of carbon and hydrogen combined. 1:1 ratio means this is 1, means that is also 1. Simplest ratio 6, how many times? 1 time. Here also 1 time. Okay, so now CH is the empirical formula of this one. CH is the empirical formula of benzene. This formula indicates that ratio of number of carbon atoms and hydrogen atoms, that is 1:1. It is also indicate that ratio of masses of carbon and hydrogen. Carbon is 12 hydrogen is 1 gram. It suggests that the weight percentage also. What is the weight percentage? Here 92.3% for this one. Remaining 7.69% is hydrogen. Combined we will get C6H6. Like empirical formula can be determined the mass percentages of various elements present in a compound. So example, the weight percentage of each constant element is taken. Weight percentage of each constant elements are taken. Now the percentage, first point, each element, constant element, percentage, weight percentage we will take. The percentage weight constants are divided with the atomic weight, divided with the atomic weight. First point, what? The weight percentage we want, or weight of each constant element is taken. Weight of each element taken. Second one is this one, divided with atomic weight. Third one, simplest whole number ratio of the values of obtained. Simplest ratio we will take. Next one, writing the whole number with suffix. Whole number as a suffix. Against the symbol of each element. These points all I will explain with example. Ionic substances have no molecules. They are represented only by their empirical formula only. Example, NaCl, empirical formula MgCl2. This is only empirical formula. Like ionic compounds, there is no molecular formula, so only covalent compounds. So now these 4 points I will explain here. The weight of each element. For example, I am taking weight percentage 48.76% of carbon, 8.07% of hydrogen, and then 43.7% of oxygen. What is the empirical formula of this compound? Our empirical formula, what? Molecular formula also, what? We can calculate like this. How? See, carbon for given percentage is 48.76 by 12 divided with the atomic weight 12, 8.07 by 1, 43.7 by 16 oxygen. Now we will get here, we can divide, means we will get 4.06 here, 8.07 here, 2.7, like. So now this is how much? Now here 4.06 by, which is lowest number came here in this one we will get this one we will get this one we will get 2.7. So divided by 2.7. Now all, which is the simplest ratio? For that we can divide all the masses. So this mass by 2.7, this mass by 2.7, this mass by 2. We will get nearly 2 times. This is 4 times. In that 4 times, this is 1 time. So it's 2, 4, 1. So now empirical formula C, empirical formula or molecular formula, whatever it. C, how many atoms is there? 2 atoms. Hydrogen, how many atoms is? 4. Oxygen, 1 atom. C2H4O. Like this is there. So this is the empirical molecular formula. We can identify with the help of this one. They will give some percentages. So that percentage divided by atomic weight. The percentage divided by atomic weight. We will get some value. In that 3 values, which is the lowest value, that lowest value we can divide with all the masses. So then all the values we will get some values, 3 different values, 2:2, 4:1. So in this 2 means carbon atoms 2, 4 hydrogens, 1 oxygen. Formula is this one, that is CH3OH, CH3CHO. this is aldehyde. So like this we will identify. This is the about empirical formula. Next, molecular formula. So molecular formula means actual number of atoms present in a molecule. It is expressed as actual number of atoms present in a molecule or compound. Is called molecular formula. So molecular formula means that. So the molecular formula of benzene is, example, molecular formula of benzene is C6H6. Indicates that benzene have 6 atoms of oxygen, 6 atoms of hydrogen combined. So molecular formula we want, molecular formula equal to N into empirical formula. Empirical formula. So we want N first means what? N is equal to molecular formula mass, molecular formula mass by empirical formula mass. N we want means molecular formula mass by empirical formula, we will get N. If molecular formula we want means N into empirical formula. So I will give one example, you can understand. So here the empirical formula may be same for different compounds. What is that? Empirical formula same for different compounds. How, sir? Empirical formula may be same for some different compounds also. How? See, formaldehyde, comma acetic acid, comma glucose have same empirical formula. How same empirical formula, sir? For that empirical formula is CH2O only. This is CH2O for all empirical formula of all these: acetic acid, formaldehyde, glucose, all. How? See, N is equal to 1 for formaldehyde, N equal to 2 for acetic acid, N equal to 6 for glucose. How, sir? See, CH2O into 1, we will get 1 into that formaldehyde means HCOH, no formula. This is only, but I am I am writing for expansion form. See, HCOH means formaldehyde. So 1, N is equal to 1. If N 2 into CH2O means what will come? C into 2, C2, H4, O2, C2H4O2. This is acetic acid means expansion form, CH3 COOH. See, 2 oxygen atoms, 4 hydrogen atoms, 2 carbon atoms is there. See, 2 carbon atoms, 4 hydrogen atoms and 2 oxygen atoms. This is acetic acid. If N is equal to 6 means See this one, CH2O into 6, C6 H12, 6 into 2 12, 6 into O, O6, C6 H12O6. This is glucose. So empirical formula of all these three are same, but molecular formulas are different. Molecular formula is C2H4O2, CH2O. This is C6H12O6. So N value is difference is there. So now I will explain clearly about this. Methane molecular formula CH4, same empirical formula also CH4, empirical molecular, same like ethane molecular formula C2H6, empirical formula CH3. So simplest ratio only empirical formula, no, simplest ratio. This is molecular formula. Actual number of atoms present in a molecule is known as molecular formula. Okay, now acetylene C2H2 molecular formula, CH is empirical formula. Okay, hydrogen peroxide C2H2 molecular formula, CH empirical formula, sorry, H2O2, hydrogen peroxide H2O2, H2O2, HO. So this is the empirical formula. But water H2O, empirical formula also H2O, cannot divided, no, so that one. CO2, empirical formula also CO2. Like this is about empirical formula and molecular formula differences. Now one formula I said before, that is what N is equal to molecular formula, N is equal to molecular formula weight or mass by empirical formula weight or mass. For this one, same one more formula is there, that is molecular formula is equal to N into empirical formula. I will give one question for brominated alkane and analysis give 12.8 percentage of carbon and 2.1 percentage of hydrogen and 2.1 percentage hydrogen, and its if its vapor density is 93.95, what is the 93.95, what is the its molecular formula, what is the its molecular formula? So molecular formula means N into empirical formula only, no. In this question we can apply these two formulas. Molecular formula, they are asking molecular formula. Percentage composition they given. Brominated alkane means bromine also is there. Carbon, hydrogen and bromine also is there. Bromine percentage they won't give, but carbon, hydrogen percentage they given. So percentage weight of bromine we want means solution percent weight of bromine is equal to, if we can 100 only, no, 2.1 no, 12.8, we can remove from this, from 100 we can remove this one, 100 minus carbon percentage and oxygen percentage, hydrogen percentage, both carbon remove percentage, remove carbon percentage plus hydrogen percentage. So what is that? 100 minus carbon plus hydrogen, how much? 14.9 percentage, because 21 2.1 no, 12.8. So we can remove means we will get 85.1 percentage for 81.1 for which one? Bromine. Now carbon is to hydrogen is to bromine. What we will do? Carbon is to carbon 12.8 by its atomic weight is to 2.1 by hydrogen atomic weight is to 85.1 by its weight, 80 grams. Hydrogen and bromine is 80 grams. So now this is atomic weights of hydrogen, carbon and bromine. So empirical formula is, empirical formula, how we can find this is 2.1 means one time, sorry, 2.1 means this is exactly one time, 1 is to, this is a 2 time, 2 is to, this is also like 1 time 1. So exactly divided, not but we can take like this, 1 time, this is 1 time, this is 2 times. So now empirical formula is, now empirical formula is CH2Br, because this one atom carbon, 2 atoms hydrogen, 1 atom for bromine. This is empirical formula. Now molecular formula, molecular weight we don't know. Molecular weight we don't know. We want molecular weight. Molecular weight we want means molecular weight means how many number of atoms is there we don't know. Carbon is 1 atom, hydrogen is 2 atoms, bromine is 1 atom, are different. That weight we don't know, but we want to calculate that weight means what we will do? Molecular formula weight is equal to, molecular formula we want molecular formula into n into empirical formula. No, that n, how we can find this formula? N is equal to molecular formula weight by empirical formula. Molecular formula weight also we don't know, no. So that only they given vapor density. Density means mass by volume percentage only, no. So that vapor density this much they given means molecular weight is equal to 2 into vapor density. Molecular weight means formula that only, 2 into its vapor density, 93.95. 2 into 93.95, we will get 187.9. This is formula only, vapor density formula what? 2 into molecular, 2 into vapor density. Okay, now here 187.9. So now n is equal to, n how much we don't know, no. N how much we don't know, n how much we don't know. N is equal to What is the molecular formula weight by empirical formula? 187.9 by empirical formula mass we want. Empirical formula mass how much? Already we know that is 1 atom for hydrogen carbon weight, 2 atoms is there, empirical 2 atoms is there, that is this is 1 atom 80. So this all we can calculate, means this is empirical formula CH2Br. C means 12 grams, H2 means 2 grams. How we know weight by its atomic weights? We will get this formula, this number. This is the empirical formula. We can multiply with that. 1 carbon, 2 hydrogens, 1 bromine. So weight of these empirical formula is 94. 80 plus 14, 94. So 187.9 by 94, n we will get 2. N we will get 2. Now we have one formula. Molecular formula we want means is it n into its empirical formula. N how much? Empirical formula means this one, CH2Br. This is only empirical formula. N means 2 now. Now 2 into CH2Br. Now formula what? C. 2 into C, C2. 2 into H2, 4. 2 into Br, Br2. C2, H4, Br2. This is the molecular formula of compound, given compound. Once again I will explain. We want N means molecular formula weight by empirical formula weight. Molecular formula we want means N into empirical formula. So in given compound, brominated alkane is the analysis. They given 12.8% of carbon and 2.1% of hydrogen. Remaining bromine they won't give. Yes sir, its vapor density is 93.95. What is the molecular formula? Molecular formula they are asking directly. So directly molecular formula will come? No. So what we will do? Percentage weight of bromine we should find out first. So 100 minus carbon percentage, hydrogen percentage we can remove, means we will get 85.1 percentage bromine is there in the given compound analysis. Okay, in that 12.8 percentage carbon by its atomic weight 12, 2.1 percentage of hydrogen by its atomic weight 1, 85.1 percentage of bromine by its atomic weight, we will get one value, that is 1:2:1. That means 1 bromine atom, 2 hydrogen atoms, 1 carbon atom, 1 carbon atom, 1 hydrogen, 2 hydrogen atoms, 1 bromine atom is there. So this is the empirical formula, CH2Br, that is empirical formula. Empirical formula weight how much? C means 12, H2 means 2 grams, bromine is 8 grams, 98 empirical formula weight we are getting. So empirical formula weight to empirical formula we know. Now N we don't know. So N we have to find out. How? Molecular formula weight by empirical formula weight. So empirical formula weight 94 we get, molecular formula weight we didn't get. So molecular formula weight we want means molecular weight is equal to 2 into vapor density. Vapor density they given, no, we will get 187.9 molecular weight. So N is equal to 187.9 by 94. Now N is 2. N is 2. So now 2 into empirical formula, we will get molecular formula. Molecular formula weight not, molecular formula we are getting. So that formula is this one. Thank you.